Oh, which way do I want to go? Let's go this way. Okay. All right. So, we just barely got into chapter 10 last time. So, every section in chapter 10 uses the exact same 5 steps. Allow that to be nice, right? Don't the same. Thank God the same 5 steps. They just use different formulas, right? So what we got into last time, I just wanted to show you what the formula would look like if I had 2 samples I was testing, right? So what's been sort of not really artificial, but not the thing that happens the most. What happens the most is I have this population over here. I have the population of ducks in this pond, and I have a population of ducks in that pond, and I want to compare their body weight to see, which one's healthier. Do you guys kind of follow?
Yeah.
So I got 2 samples I'm going to take. Do I know a damn thing about the population of ducks? Not necessarily. It's just I just saw these ducks and I'm like, those ducks look fat. Those don't know. Let's see if there really is a difference. And if there is a difference, then I can do more specific tests on each site to see what it is. Is there more food? Obviously, that would be the first thing I look for. Whatever. Genetic differences, possibly. Who knows? Anyway, that's all beyond. All right, so you guys are kind of with me? So that's the idea behind chapter 10. Chapter 9 was all about comparing, having a claim about some assumed number, that the population really was this. So somehow we know what mu is. Chapter 10 says we don't know shit about mu. We just want to see if these 2 samples are different enough from each other. Okay, so the formula we came up with kind of makes sense. That I take the difference between the samples. I want to see how different they are. Now the standard deviation, we had to beef that up a bit. Just to remind you guys, we used this fact. Let's see. That's true. That's algebraically, mathematically true, especially because everything's positive in here. There might be some little things to be careful of. They were allowed to be negative, but nothing's allowed to be negative. Yeah, negative people, you can have a negative variance, right? So what we do is we have one variance for one group. That could be like duck pond 1. Sounds like a horrible, this is duck pond 1. Come in. Plus, we can have a standard deviation for duck pond 2. The return. Duck pond 2. This time. All right, I'll start. So that's what it looks like. So compared to what we used before, we had one sample that we compared to some assumed mean. So mean, we're like, yeah, assuming that's right. Let's see how different I can get from a sample. Divided by, of course, our single, just to put the whole formula in here once. That was what T-star was before, right? So now I got 2 of these instead of 1 of them. Where'd the mu's go? Who remembers what happened there?
Cancel each other out.
Yeah, because what's the assumption that I'm always fighting against? So if I look at it and say, oh, that duck pond, those ducks look healthier than those do. So I'm trying to prove that those ducks are healthier. So what am I kind of fighting against? That the ducks are actually exactly the same. I'm trying to say that they're not the same somehow, right? So if my null always has this possibility, then if I did put 2 mu's in there to kind of have the same, that would just cancel each other out. Okay, so that's a remarkably quick synopsis of what we did at the end of last class to get to this formula. All that really, really happened was everywhere I see one thing, I put 2 of them. 1 X bar, 2. 1 and 2. 1 and 2. All right, sweet, because I got 2 freaking samples I'm doing. Okay, so let that part be nice. It's almost too good to believe, to be honest, that it's going to be exactly the same steps. That kicks so much ass. So, let's immediately do an example together. Let's see if you guys can handle this. The side that references 10.1. Stick with that. The one talking about grades. I lost so many people.
Tragic.
I know.
Did a lot of people drop?
No, I mean just now after the quiz. And I'm worried that they thought that was it.
That's even more trash.
What's more trash is the people that didn't drop, but they don't come to class. That's trash. Oh, scheiße. Yes. Mer, scheiße. I know how to say it in sign language. It is a very good word to know how to say it in several different ways. Oh, good. All right, that worked out.
So what would this be? Is this 10.2 that we're going to do? Oh, wait,
10.1.
No, 10.1. Thank you.
10.2, the funny thing is 10.1 is S's here, so we're going to use T-scores. 10.2 is sigmas here. So then we would use, who cares? So the one thing we got to figure out on the way through this, I don't think I put it down here. Oh yeah, I did. I told you, okay. How to figure out the degrees of freedom when I have two samples. So there's a very complicated formula that we're not going to use. We're just going to use the accepted alternate way, which is take the smaller sample size. Always, whenever we have to make a choice between two things, we choose to be more conservative. We make our test harder to pass if there's something I'm not sure about. Well, which sample do you? I don't know. Let's use a smaller one then to make it a little harder to pass. Let's cover our ass for something we don't know. Okay. So let's do this one together. Because the hypotheses are not going to be written in exactly the same way, because now I'm not comparing it to some known value. I'm comparing two different populations, like the population of ducks over there and the population of ducks over there, by taking samples of both. So, Panasonic. Oh, jeez, now it's great. Sorry. Panasonic. Old song. It's stuck in my brain now. Did they do it to somebody else? All right, good.
Yeah, thank you.
You must share them when that happens. All right, here we go. So read through this real quick, if you haven't already. And one little thing, being as bad as a book, it's normal enough. I don't think I say that anywhere. Oh, screw it.
Can't see it.
It says normal enough. It's way bright. Still can't read it, I know. Normal enough. Blah. So the difference here is, again, so just like I have x bar 1 and x bar 2, I'm going to have mu 1 and mu 2. So like I said last time, what's really important, the very first important thing to do is identify which group is the 1s and which group is the 2s. They're just two different groups. Doesn't mean I like the 1s better. I like you guys. No, it's, so the first thing I see here is women. So let's make women 1. And men, we'll make group 2. Doesn't matter. If you do it the other way around, the math is not actually going to end up carrying. So what is the claim?
They're the same.
Yeah, good. So the claim is that mu 1 equals mu 2.
What would you say, sample?
No. I'm never going to have a claim about the samples because I can see them. I wouldn't. Why would I have a claim? I claim that you're wearing a hat. I can see that. It's what a great going out on the limb, right? Ooh, Jeff, that's awesome. Do you guys kind of see what I'm saying? So you never make a claim about sample. Your sample information will never show up in step 1 because you know that shit for sure. There's no claims to make. I know what the sample stuff is. I see it. The means of the population, I don't have a freaking clue about. So my claim is that they are the same. So which one is that?
HO.
HO. I like it. So what's H1? That's crazy. So how many tail tests will this be? 2 tail tests. What am I doing? Look at me. I'm stuck in algebra. 2 tail tests. It's hard to change modes sometimes. It's like changing gears. How are we doing so far? So when you have two samples that you're working with, basically no numbers will show up in your claims, in your HO and H1. You're comparing two groups. You're not comparing it to a set number. So that's the first difference from what we were doing before. So this is sort of the same. Since I added in normal enough, right? I was as bad as the book there at first, I'm sorry. Well, we know it's normal, check. Check. So I don't care how big the sample is, they told me it was already normal. I don't need 30 to make it normal, it's already normal. What's the second thing I need to look at? What kind of standard deviations do I have? Sample standard deviations. So I have sigmas unknown. So I must use what? T-scores. I like it. Boy, oh boy. It's not to say it's a bad day for me in writing, but when is it a good day for me in writing? I haven't had that day yet. Alright, so see, I mean, it feels the same. This is kind of nice that we have a section that's kind of new, but it's not totally, so you're still getting practice with the earlier stuff as you do it. Alright, so here's where, well, this one's not too bad because it's a two-tail test. We'll see in a minute what happens when it's a one-tail test, so we've got to be careful. But two-tail tests, alpha equals 0.05, two-tail. Degrees of freedom is what? Well, that's going to be the lesser. So what's the smaller sample size? Yeah, 22, so 22 minus 1. Is everybody cool with that? In the book, they talk about this ugly formula, remarkably ugly formula. This is a completely accepted alternate way to do it. Yes, sir?
Why is it 21?
What's the smaller sample size? And then make the degrees of freedom off of that. So what are your sample sizes?
22 and
22 and 26. So what's the smaller one?
22.
Good. And degrees of freedom is n minus 1.
Okay.
So you always do the smallest number?
Yes.
Okay.
For this kind of problem, for section 10.1. Alright. So, has somebody done that yet? I gave my last T-score chart away. Have you been able to look that up yet? Your degrees of freedom is 21. 0.05, two-tail test. 2.080. I like it. Negative 2.080. Positive 2.080. What would the if it was a z-score situation? Somebody just know what that would be? Two tails, 5%. So that means 95% on the inside. Does anybody know what that is? 1.96. I like it. Isn't this just a little bit bigger than that? All right, so that's kind of like a quick check to make sure that I got the right one. It should be a little bigger than what the z-score would have been. Right? So how do I say this in words? If T star
is less than negative 2.080 or greater than 2.080, then we can reject the whole.
I like it. Said with gusto. So, I mean, it's just saying in words what your picture says, because some of us are more visual and some of us are less visual. So I want you to do a visual for yourself and just in words, what the hell. So you can compare it either way that makes more sense. Oh, here, I should have put that up there. Oh, well. Yeah. So now you just got to plug and chug? Yes? Oh, over there. Okay, sorry. So now you just try. Put it in your calculator. So it's going to look like this here. One was the women. Oh, let's do this. So I got X bar 1 is 82.4. N1 is 22. S1 is 12.571. 84.5. N2 is 26. S2 is 8.55. I think this was true for a couple years ago, one of my stats classes. Yeah.
Just for that first part, when you said the standard deviation is unknown, just because we're using
The population standard deviation,
so we're using
sigma.
S
Yeah.
in that one.
Exactly. So that's what t-scores were invented for, to cover my ass when I only know s. I don't know the real sigma. All right, so here I just summarize for myself, and then I just plop them in there. x2. For some reason, people forget that square there on the s. Whew. Let's see what I get. Stay ahead of the controversy. So what'd you guys get? Anybody got that yet? Anybody willing to suggest what they got? You say it first, man. Anybody got something? Nobody got anything. There you go. Brave person. That's what I got. So either we're both right or we're both wrong. I don't know why I did it twice. But yeah, there it is. So that, I put the top in parentheses because the poor little calculator doesn't know what that big bar means. I got to know what the top is. And then I made sure all the rest of this stuff was under the square root. So if you didn't quite get that, you can see me after class or something. We got to get that straightened out. Okay. So negative 0.66. Did we make it far enough away? Where are we at visually? What's in the middle here? Think of. And where are we at? 8. You got it right there. Yeah. You guys with me? I mean, that's just like negative 2/3 of a step. 2/3 of a step down from the mean. That's not very far away. That is not very far away. At this point in the class, you should just intuitively know that. That is pretty damn close. Those samples are not very different from each other. How are we doing so far? I mean, look at it. 82.4 and 84.5. On the surface of it, I'd say those seem pretty far apart, right? Yes? But the standard deviations were big, weren't they?
Yeah.
So that ends up saying that, that actually isn't that big of a deal. That's why I can't just look at it and know ahead of time what's going to happen. I've got to trust the formula to tell me how truly far apart they are relative to how spread out numbers are in general in this problem. So what does that mean? What can I say right here? We failed to reject the hope. Failed to support the high. Sorry, I don't know why I'm showing you that. You can't read it, so hopefully you heard what I said as I was writing it. Failed to reject the hope. Failed to support the high. Which one was our claim?
The hope.
The hope. Cool. So we got to use that language. I don't use that language. I use this language. That's it. That's how you determine. Do I say reject or support, Jeff? When do I? God, sometimes I say this. That's it. Which one was the claim? That's the language I use. So we have not found sufficient evidence to reject the claim that what? Yeah, that men and women in this class have the same grades. So again, I would still have, number one, again, good luck on reading that. But number two, I still have people that would say, but they were different, Jeff. They were different. One was 82 and the other was 84. What the hell is all this shit? All you math people making things so complicated, they were different. So what the hell? What would you tell somebody? Maybe somebody out there says, they're right, Jeff. If you disagree with them, what would you tell them, this person that's saying that? Because I'm going to have people coming to me saying that. They are different, aren't they? They're different. So what do you mean you fail to find evidence that they're different? They are different. I can just see that they're different. But what's the they? That's the key part of that. What is the they that they're talking about, and what's the they they're supposed to be talking about? And you guys are like, I don't like that question, Jeff. Stop it with that shit. What are we trying to say something about? Yes, but what is it talking about? Is it talking about a sample? Populations. I'm trying to make a claim about a population by using a sample. And in this case, two samples from both populations. My claim is that the two populations have the same grade. I'm going to test that claim by taking samples. I already know the samples are not going to equal each other. Even if they really are exactly the same grade, if I take samples from each, I'll put money. I'll put a lot of money on them being different. Right? Because sample means will be different. They'll be close. They should be close, but they're going to be different. I know they are. So they're different, but they just weren't different enough to be enough evidence. If you're trying to prove something with a sample, the difference you see has to be large. And what defines large is alpha.
Yeah.
How large does it have to be? The alpha tells you how large it has to be. You guys kind of seeing, that's the whole fabric behind this whole type of test. Okay, maybe. All right. So, let's see how much time. Okay, we got a little bit of time. Let me give you this. Try to do this one on your own. I was exceptionally evil, and I've given you one where you have to calculate your own X bar and S. Use 1 bar stats in the calculator. If somebody starts making a table, oh my god. You don't have to do that anymore. I don't know. At least 1, at most 2. It's a very math answer. Expect on average about 1.5. So if you, I think all my calculators are out there. If you're going to work with somebody on this, it's beautiful. One of you guys can do the females and one of you guys can do the males.